In this video, you're going to get guidance from Math Boxes 510. We'll be working on measuring angles, drawing angles, area, and the perimeter of squares and rectangles. For number 1, you will need a protractor to measure the angle. Now, with your angle, you'll want to line up the vertex. The vertex is where both rays meet with this little dot, okay? That's your central angle, I guess you could say. That's what we're measuring. At the top, you have degree measurements. And also notice that right below, you have degree measurements as well in a different color. Now, they're both degrees, but what you have to do is you have to pay attention to what direction that angle opens up into. So if you had a measure of an angle that looked like this, okay, we're going to take our vertex right there, and we're going to put that central part of the protractor on top. Notice how this line right here should be parallel or continuing of your extended ray. When we mark our line, what I do always is using that protractor, I just make a little notch in where your line or your ray crosses. So I have my notch right between 110 degrees and 120 degrees. Now 110 and 120 right in the middle is 115. But wait a minute, that doesn't make any sense to me at all, because I know that an obtuse angle is greater than 90 degrees. And a 90-degree angle is like a corner. Think of a corner of an iPad or the corner of a desk. So obtuse is 90 or more, which is 115. And when I look at this angle right here, that is not bigger than 90 degrees. So that's why they have those bottom numbers right here. And when I look at the bottom numbers, I'm going to see it's 70 and 60. Well, what's between 70 and 60? 65 degrees. And a 0, which we're not going to have a 0 angle, so we can say a 1-degree angle to a 89-degree angle would be acute. And we can see that this angle is an acute angle. So when you're measuring, make sure you line up your vertex with that central point. You measure, you extend those lines, those rays, but also make sure that we're using the correct numbers, okay? We shouldn't be using in above the 90 degrees if it's an obtuse, and we shouldn't be using above the 90 degrees if it's an acute angle, and we shouldn't be using below the 90 degrees if it's an obtuse angle. So be mindful of those degree numbers. For number 2, you're actually using a protractor to draw an angle and to measure it with a certain degree measurement. So let's say I was asked to measure an angle that was 175 degrees. That is an obtuse angle, so we know our measurement is going to be greater than 90. Okay, that would be a corner. So the first thing I'm going to do is I'm going to make a dot right at my central angle point, and then I'm going to draw or use that edge of that protractor to level it out. And I always extend my lines much farther than I need to because it gives me a more accurate form of measurement. So 175, that means, like I said, it was obtuse. So I'm going to go here and I'm going to go all the way to that other side into 175 right there. I'm going to make a tick mark, and then I'm going to connect from here a line all the way to 175. Notice that's super close to a straight line because a straight line is 180 degrees. So remember, your helpful tip is to extend those rays that you're measuring much longer than you think you need to. With angles, you don't want to try to write and make them as teeny tiny as you can. You want to make them big. So for those of you who love to write big, keep that up when you're measuring angles. For number 3, we'll be finding the perimeter in the area of a rectangle or a square. Now remember, the perimeter is the distance around the outside. Okay, it's like you're taking a walk around the block. Or you're measuring around a door frame. Whereas the area is the distance inside. It's the amount of space that gets covered. So for my perimeter, what you do is you add up the lengths of all sides of the shape. Now in this case, we have squares, so it's the length of each of the sides will give you your perimeter. If you're working backwards, okay, you already have your perimeter. You know in this case, we know this is 14 and we know this is 14. So 14 plus 14 plus some number, and we know opposite sides of a rectangle are the same, is going to give me the perimeter of 42. 14 and 14, that's 28. Plus S, remember these are the same numbers, so we could say it's 2S, is 42. Now, we have to get the variable all by itself, so S plus S, or 2S, is going to be the same as 42 subtract 28, which is 14. So some number times 2 is the same as 14. That will give you your dimension for your missing side. Now for B, you're given the perimeter of a square. Now of a square, you know that each side is the exact same length. So that means what you could do is you could take your perimeter, which is 28, and you could split that 28 up into 1, 2, 3, 4 sides. So it's kind of like you're uncurling that rectangle. You're splitting it into 4 equal parts, or that square into 4 equal parts. So when you do that, all you need to do is divide. Now the next 2 problems dealing with area. And remember, area is the amount of space inside of shape, the number of square units that are inside the shape. So you have a 17 by some number, your height, and you know that the amount inside here is 51, okay? So I know 17 plus 17, I'm kind of working backwards here, is 34, and then 34 plus 17 again is 51. So I had a 17 this way, and how many do I have this way? A 3. 1, 2, 3. So my height must be 3. I want you to use that by trying to think of how many increments of 13 can you repeatedly add, because multiplication is the same as repeated addition, to get up to 78. The last 2 questions that you have are word problems. So the art room at Walker School is 27 feet long. There's one dimension right there, and 38 feet wide. There's another dimension. So what's the area of the room? Draw a picture. Find or label the length of each side. Use your formula. Area is the same as length times width. Put your dimensions in and solve for the area of the room. That was number 4. Now for number 5, you have that Mia's backyard is 25 feet by 50 feet. Once again, you have 2 dimensions. Okay, so draw a picture for Mia's, and label. Okay, then you also have Joy. Now Joy has a backyard, again, in 2 dimensions for Joy, 35 by 35. It says who has the bigger backyard and then how much bigger. Well, in order to find out who has the bigger backyard, first you're going to have to find the area of Mia's backyard and the area of Joy's backyard. And then you'll want to compare to find the greater backyard. Which one's bigger? Second question is, how much bigger? Well, how much bigger? That should give you a clue to the operation that you're using. Are you adding, subtracting, multiplying, or dividing? I hope you found those tips helpful when measuring angles, finding the area and the perimeter of squares and rectangles.